Good afternoon and welcome to this month's show. I'm Luke McCormack. During today's show, we will discuss best practices with machine learning and artificial intelligence strategies in the federal government. With me on today's show are William T. Roberts, we'll call you Buzz, Lead Analytics for Automation Research Directorate, National Geospatial-Intelligence Agency, NGA, Frank Indiviglio, Acting Deputy Director, High Performance Computing and Communications, National Oceanic and Atmospheric Administration, NOAA. Dr. John Beieler, Program Manager, Intelligence, Advanced Research Projects Activity, IARPA, Office of the Director of National Intelligence, ODNI. Bob Armstrong, Chief Technology Officer, ServiceNow Federal, and Tyler Muth, Analytics Architect at Splunk. Well, this is a big subject. I think we're all familiar with what happened with Watson in the famous chess match. Some of you may or may not know of a game called Go that is widely played over in Europe and across the East, played by millions of folks. There was an anticipation that a machine could not beat the top Go player for at least 25 years, if ever. Program was put together called AlphaGo, beat the top Go player handedly first time out. I understand now that the program is capable of actually beating the top 50 players simultaneously. So we know where this is going, right? We have natural learning, processing, deep learning, all kinds of activities, acquisition issues, skills issues, data bias issues, a whole host of issues that get rolled into this emerging and very rapid and important technology. So let's start with you, Buzz, over at the NGA. Tell us a little bit about what's going on in regards to machine learning and AI at the NGA.
Thanks, Luke. So from our perspective, our challenge is a bit harder than Go, I would argue. Sure. One, most of our issues, unlike Go, are an open-ended issue. Go has a specific objective with a specific number of moves and a specific bounded region it plays in. We have global responsibilities. So our challenge is fundamentally to master the deluge of data, sift through that data and information as quickly as we can, and increase the accuracy, pedigree, and quality of those results. So we're organized in several different fashions and in several different ways in terms of getting clarity of our objectives, both operationally, clarity of our objectives technically, and understanding that we pay what I'll call our debt in three areas. The technical debt of understanding the advanced methods, the debt of understanding our data, and the data that we get directly and the data that we get indirectly through partnerships, and understanding our domain. From a geospatial intelligence perspective, many people don't understand or grasp that we actually do have a worldwide open mission to provide safety of navigation that affects every human on the planet in terms of what anytime you step on an aircraft and anytime you step on a vessel. So there are a lot of different things that we do, and we have to be right. Think of this safety of navigation thing. You've had a GPS send you in the wrong direction. Well, we can't do that. We can't afford that. So as we move forward, debt in all those three areas, how do we leverage what's emerging, apply it to our problems to ensure we have accurate delivery of the information to all those who need it for decisions and intelligence.
That's interesting. I don't think a lot of folks, certainly I didn't, probably a lot of folks in the audience that didn't realize that NGA had that open mission. Speaking of an open mission that is near and dear to everyone's heart, certainly in America and on the East Coast these days, is Noaa. Mm-hmm. Frank, tell us what's going on in regards to machine learning, artificial intelligence. How is this technology solving these problems and making sure that we're all staying safe?
Mm-hmm. So I think the goal across the agency is to improve forecasting, improve warning systems that we have in place for weather events, extreme events. But more broadly, it's being applied across Noaa for a lot of a variety of problems that we face from in fisheries for species identification, so managing endangered species, and then more broadly all the species we monitor in the marine environment, getting down from just not estimating population but identifying individual individuals within that population. So there's work in the right role population to make sure that we know, individuals in the population so we can track them and make sure that we're watching,
And I heard
monitoring
there
the
was a new
endangered
species that just got identified. I don't know if that was you all that did or somebody that did that just recently.
Yeah,
Yeah.
I don't know if that was us or another folks, but that's the kind of, and expanding on that, in the marine ecosystem, we tend to model things on a species by species basis, but machine learning is helping us expand that to model ecosystem interactions and give us give the public a fuller picture of that ecosystem.
Right.
And then on the forecast side, we're moving into machine learning to look at smaller events like hail size and hail distribution, learning from what we have from observations and models in the storms, and giving a better an improved warning system out to folks in affected areas by maximum hail size and spatial distribution of the hail that'll be falling, and then improve forecasting in tropical events. So identifying areas where tropical cyclones will happen, and then all the way down to tornadoes. So
Right.
improving the modeling and mission that's already happening, and enhancing that through machine learning is kind of the direction that NOAA's going.
Right. I would imagine that heavy-duty modeling is getting into some predictive estimates of those capabilities too. Well, speaking of modeling and analyzing data, Tyler, I know Splunk does that in spades. And let's hear about what's going on in regards to Splunk in respect to using this type of technology as it collects vast amounts of information across the community, not only the federal community, but certainly in the private sector community as well.
Sure. Thank you, Luke. So, we are primarily focused on machine-generated data, and so we've been applying machine learning to that data in our products for years. And right now we're making big investments in two areas: in enhancing those products to have built-in capabilities using machine learning to either predict or detect things that we couldn't easily do in the past, and also building out more features in our custom machine learning area with our machine learning toolkit. So we're offering customers the pre-built solutions to rapidly see value, and also offering them more capabilities if they have data science capabilities in-house, excuse me, to further build out their own custom machine learning capabilities.
So interesting. So not only are you using the technology to provide sort of an outcome capability to them, but you're actually giving them a tool set that they can use.
Right, right. And I see that
interesting.
To be successful in data science, you have to have the tools, you have to have the knowledge of data science, but you also have some domain expertise. And so for those areas where we already, do a lot of work in IT operations and security, we can provide package solutions for that. But there are other areas where customers are already getting data and they want to take it the next step. We're providing the tool set so that they can take their domain expertise and apply it to their data.
Okay, interesting. Bob, how about at ServiceNow? You guys have a broad footprint out there. You're seeing a lot of information that's getting more and more sophisticated, increasing as you guys broaden your scope, not only, again, in the federal market, but certainly in the private sector as well. Tell us a little bit about what's happening at ServiceNow in regards to using machine learning and AI, et cetera.
Well, good afternoon, Luke, and thanks a lot for hosting this exciting topic, right?
Yeah.
So we're all being conditioned to use artificial intelligence in our daily lives, right? So we utilize intelligent agents every day, whether it be Alexis or Siri, to help us make decisions and bring information from various data sources and present it to us so we can make decisions in our personal lives every day. That expectation is really being seen by federal agency employees internally and by citizens who are taking advantage of the output of the various agencies. So what we see at ServiceNow is really this blending of information that's being presented to humans to be able to make the appropriate decisions. So we kind of look at AI from a different lens. There are a lot of focused technologies that are being applied within various lines of business. I mean, Frank, he's got a huge mission with Noaa, and Buzz is really doing cool stuff at NGA. We partner with our partner companies like Splunk, and Tyler talked about what they're doing on the platform. We look at it as practical AI. How do we bring in machine learning and the ability to augment human decision making to make our way that we do work much better today than we have in the past?
Right, and I would imagine that, Noaa, NGA, and certainly John over at ODNI, that you guys are, doing this at scale, right? I mean, the scale and capacity is just absolutely phenomenal. So tell us a little bit about how that activity is going over at ODNI in respect to, where do they play the role as they coordinate across the intelligence community in respect to using this technology?
Right. So I sit at IARPA, and we're a little bit different than other people at the table in that we're a basic research and development agency. So our goal is to build some of the tech that some of these other folks will use. And towards that end, we have lots of programs that we run, large multi-year research and development efforts that make use of or focus explicitly on machine learning or artificial intelligence. So to provide a few examples, we have a program called DIVA, which is focused on action detection and video from multiple cameras. This is things like someone picking something up or putting something down from something like CCTV footage. We have a program called Microns, which is focused on brain science, neuroscience, and imaging the brain and the cortical network to get a better idea of how the brain works and how humans learn, to see if we can maybe apply that to machine learning or deep learning, because the main deep learning technique is neural networks, neural as in the brain, and that's really based on an outdated and antiquated notion of how the brain works from the 50s or 60s. So Microns is focusing on how can we learn some better lessons about the brain to apply to new ML techniques. And then the program that's nearest and dearest to my heart is my program called Better, that focuses on how we can do improved information extraction from unstructured text content to better do document triage and retrieval for an analyst. So that's things on the IARPA end, but at the broader ODNI level, there's also the AIM initiative, Augmenting Intelligence with Machines. It's explicitly not artificial intelligence with machines. So because it's supposed to articulate that the end goal is to augment our human intelligence analysts. And how do we do that? A lot of that will be through ML and AI, but not exclusively. So at the broad ODNI level, we're trying to figure out how we can use some of these techniques to make our analysts better and improve the work that they do and augment the great knowledge that a lot of our analysts have.
Right, and I know there's a delicate balance, and it's a fine point there about augmenting versus having a machine make that decision. And somebody said the other day, yeah, really what we're trying to do is get the machine out of the human so that they can continue to focus their attention on this higher order thinking, if you will. Well, let's ask you, Frank, at Noaa, can you give us a specific program that you guys are working on that you'd like to highlight, something that would be of interest to the community, that you're using this technology, whether it's machine learning, AI, all of the above, and to sort of exploit the Noaa mission?
Sure. Thanks. So I think one of the programs that has been successful in exploiting AI or machine learning, depending on how you look at it, is a program within the National Environmental Satellite and Data Information Service. So they've actually stood up a pilot program to aid data assimilation of satellite data and sensor data coming in. So that's the critical component in the forecasts, right? So these become the initial conditions of all the models that go into forecast products. And they've been able to reduce their compute time by an order of magnitude and preserve correctness and full resolution of the data, so they can deliver a product in a much quicker time frame than they have been in the past, and they're going to grow that capability out to improve the forecast overall.
Fraction of the time and much higher order, and I know it's just sort of using that data to sort of feed the model and making it much more predictable is a key part of this technology.
And exploit the data, the full set of data that's available, right? So everybody, I think, at this table and maybe listening knows that the more you look at a problem, the bigger it gets, right? So the more data that we have, the more we can exploit, but it's harder to kind of pull that all in. So that these are the kind of technologies that we can use to fully exploit the data that's available through sensors and satellite imagery and
Interesting,
observations.
because you're getting much more access to much more collected data, right? Because of Internet of Things and all these other activities that are going on. I saw there was 250,000 personal weather stations out there, I guess they call them, which is incredible if you think about the math on that. And then there's a lot more computing capability to compute this kind of this different types of data that's being collected. Tyler, how about at Splunk? Tell us a specific example of some technology that's being exploited to the greater good.
Sure. So TransUnion is one of our public examples right now. And they are using machine learning to detect.
And TransUnion is what, for those that may or may not know?
They are an entity in the banking industry, right? So my public sector references aren't public right now. So
yeah, no, I understand.
And so they are working with many of the large banks, and one of the things they're doing with machine learning is detecting traffic patterns and applying machine learning to that. And so we can, if you look at traffic patterns like you might see, you can think of it like traffic flow in a big city during rush hour, right? It's very predictable, right? And so being able to model the traffic patterns and see when things fall outside of that can be an indication of an attack, right? And that's one of the methods they're using. We also have Hyatt Hotels using machine learning to detect the end user experience of their Wi-Fi. And we've all experienced hotel Wi-Fi and how bad it can be. And they are applying machine learning to that problem and detecting a bad customer experience with ML, and then automatically filing tickets with their service provider of Wi-Fi so that they can greatly reduce the time to resolution on that.
Fantastic. Buzz, how about at NGA? Can you give us a specific example of where this technology is being used?
Yeah, I sure can, Frank. So back to that, our global responsibility for safety of navigation. So we have a program called Notice to Mariners that provides worldwide navigational updates to hazards, objects, be they static or even dynamic. So when Fukushima exploded, there were floating debris within the Pacific Ocean. So there's a responsibility to make sure the flow of goods and services can go, as well as the safety of people. It's a small crew working to try to sift through a global set of information. We've used various elements of AI to try to augment their tasks, sift and filter through data, and have now reduced that backlog from years to months, and then hopefully in the near-time future we'll bring that to a currency that drives the data to decision timeline to as close to zero as possible.
Wow.
The same thing will then be applied to our aeronautical safety of navigation. So our goal is to ensure that the understanding of the world that we're responsible for is as timely as it can be. If I could, I'd like to mention then a second aspect. Without giving away too much of our classified mission, we really feel compelled to educate the open community on what it's like to deal with our data in our domain. So partnering with the Defense Intelligence Unit, DIU, formerly DIUX, we've published a set of unclassified data and a challenge out to the open community called the XView data set, the XView challenge. So folks can come in thinking they have potential solutions, look at examples of our data, examples of the classes or the objects that we're interested in, and see if they can actually contribute. So we're doing two things, trying to educate the open community what's unique about us. And what's unique is, imagine doing facial recognition for your iPhone, which is a great thing. You've got it, it works while it's 1 to 2 feet in front of you. Ask your friend to hold that at the 0 line on a football field and walk back in 10-yard increments and see how well that works. Well, the parallel is, imagine trying to do facial recognition from the 50 or opposite end goal line. That's our job.
It's incredible. It's like the X Prize for NGA, so to speak. Very interesting projects on a very interesting topic and very interesting subject. We're going to take a short break. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com. With me on today's show are Buzz Roberts, NGA, Frank Indiviglio at Noaa, Dr. John Beieler, ODNI, Bob Osborn, ServiceNow Federal, and Tyler Muth, Analytics and Architect at Splunk. We were talking about machine learning, we're talking about AI, we're talking about specific projects and programs. And I'm going to throw it over to Splunk and ask you, Bob, about a specific project that you guys have been working on over there that may be of interest to the community.
Well, you know, Luke, it's really interesting because at ServiceNow we're seeing that, you mentioned it previously, the Internet of Things is really important to folks as you look at bringing in data from a multitude of different sensors and inputs across the enterprise. And we're focusing on delivering enterprise solutions. We actually refer to it as the service-aware enterprise, and that's taking machine learning. I mean, we heard Tyler talk about it before the break, right? It's normalizing what routine activities look like within the enterprise and then applying machine learning and artificial intelligence algorithms to be able to quickly identify anomalous behavior so that you really understand when something's happening in the enterprise and be able to respond to that in an automated, very fast fashion.
And sorry about that. I think I said Splunk and ServiceNow, and I know I called you Armstrong instead of Osborn, so I got you all bollocks up there, Bob. Sorry.
Not a problem, Luke Skywalker.
All right. May the force be with you. All right, how about at ODNI? How are we doing down there in regards to specific projects and programs, perhaps one that you can talk about?
Right.
And I know you guys are probably working very heavily with In-Q-Tel on a lot of these activities as well, right?
Right.
Yeah.
So do talk a fair amount with our colleagues at In-Q-Tel. Obviously, In-Q-Tel is focused more on the startup community and finished products, where I personally at IARPA, again, focus more on the basic R&D and hope to build out some of the tools that might be useful in the final products that a startup would build, right? So some of the techniques, the machine learning techniques that we're hoping to develop, you know, that trickles down in things like natural language processing or human language technology to then be incorporated into a startup's product. Additionally, again, since we're focusing on basic R&D, we don't have kind of nuts and bolts projects the way that some of the other people at the table do. But similar to what Buzz mentioned earlier about some of the public prize challenges, IARPA is also very big on opening up to a non-traditional performer base. So we tend to run lots of public challenges. We have lots on Face ID, facial recognition and unconstrained settings, right? This is things other than mugshot photos. How can we identify faces? A prize challenge that I run is the Mercury Challenge, which is using open data, can we forecast societal events, things like civil unrest or military activity. And again, these are open challenges. These aren't funded efforts the way we tend to fund R&D. There's a prize purse associated with it. We release some data, and then we reach out to the hobbyist community, as we like to say, to see what solutions they can bring to the table.
Yeah, it's incredible some of the stuff that's been going on with crowdsourcing, right? I mean, it's just phenomenal what's out there and available, that you know, sort of the brain power, and this gets back to the X Prizes, right? So I'd always like to talk about lessons learned, and since you all I would consider the early adopters of this technology and sort of working your way through this, and I think about things like acquisitions and skills and data bias and some of these things that we had mentioned earlier in the show. Let's start with you, Buzz, in regards to just sort of some of the lessons learned that you'd like to share with the community as they're start to embark on this journey of adopting this technology, that you know, things that they ought to be thinking about.
Luke, from my perspective, it goes back to those three debts, and that is your technical debt, your domain debt, and your data debt. Clarity of objectives, absolutely the best thing to start with. What purpose are we trying to achieve? What are the factors involved in that purpose? What are the data elements and sources that you're trying to advantage? How do they all interplay, and what are the best methods to solve that? In some cases, that may be machine learning. In other cases, it may not be. and don't walk in with a bias or a prejudice to any one method, any one source, and that is an element of deliberate planning and focus that establishes all the successes that I've seen. Most of the failures have been when we rush to too quick a decision, too quick an assumption that this solution will be uniformly applicable across all things. That's guided our achievements and our successes, and it gets us to a common point of understanding. And then hopefully, as you have one success, you understand that approach, method, the due diligence involved, you're not starting from square one the next time you try to solve that. So you're educating your workforce, your practitioner level, your scientists, your technologists, your operations research, and your end customers and decision makers that you're trying to support. So in theory, you're growing the skill sets as you spend time getting clarity of objectives so that you can go faster and increase your performance, speed, and agility over time.
Yeah, I mean, you really do have to grow the skill sets. This is a green field, right? We're starting at zero here, so it's not like the world's got a full army of data scientists, et cetera, out there. Tyler, how about at Splunk? Tell us a little bit about, some lessons learned as you guys embarked on this technology early, it sounds like, and are, using it quite widely. Internally within the federal service and externally, and just sort of, what are you seeing out there, and perhaps what are you seeing across our community that people are perhaps stumbling on and, ought to be pointed out?
Sure. I'd love to echo the sentiment of start with a small and measurable problem, right? And maybe pick a problem that's already been solved, not something that's unique to your agency. Pick something simple like measuring storage latency, or measuring the end user experience of a web application. So you already know the solution, and build up your skills that way. I would also say that operationalizing machine learning is actually pretty difficult. There are lots of tools out there to do post-mortem analysis and print off pretty pictures of it, but taking data streaming in real time and applying ML to it and taking action on that, really operationalizing, it's tough. And so, I think thinking that through and figuring out how you want to operationalize that, what outcome do you have, what action do you want to take, is definitely one of the lessons learned in this process.
Yeah, I would imagine that starting with something simple is always important, and I would think that this, even though it's a massive amount of technology and typically need to use a lot of data to to train these models, you can still do that kind of a bite at a time. I would imagine that. Frank, how about over at Noaa? Can you give us some lessons learned? It sounds like you've been early on this journey, and certainly have experienced some things that you'd like to share with the audience.
Sure. So I think it's not that too much different from what Buzz had said and Tyler said. Kind of starting small, attacking the problem at a small scale, and giving folks space to do that work. Right. So within Noaa, we've set up a technology incubator program which allows people to kind of start small, but it allows us to scale up over a year. Right. So you start with a very small problem. And then it fosters a development path for not only to develop your idea for that problem, but to scale it out into the realm of, for us, HPC, but for the broader application set, how does it fit within Noaa? Within the HPC community at Noaa, our development time
HPC being
high performance computing. So
okay. HPC.
Yeah. Sorry. Our development time our development cycle anyway tends to have a long tail. Validation of data, validation of models, validation of code, and giving people space to start small and then grow that out into the larger community seems to be working out for us. But I think that's a measured and okay approach to getting new technologies into a very measured modeling stream.
Bob, how about at ServiceNow? What are the lessons learned that you're seeing out there that you'd like to share with the community in respect to, adopting this type of technology? Maybe some lessons learned that you guys have seen internally at ServiceNow or externally with your customers that are trying to embrace this capability.
Sure, I think Buzz hit it right on the head. You need to really focus on what are the outcomes you're trying to achieve by applying this new technology. Luke, I don't know what your experience was when you were CIO, but when I was looking at a emerging technology, it was always a challenge for me to figure out which flavor would work in my environment, which one would achieve the outcome, and I'd usually have to do a big research project on that. And then
you always had the beta,
Exactly.
VHS kind of issues that
that's
you had
right.
to deal with as well, right?
Exactly. Then
Especially
you have-
on the early adoption.
Correct. And then you have to acquire whatever the winner of that bake-off is, if you will, and then integrate it into your environment in order to actually get the outcomes you were looking for. When you're talking about specific applications around artificial intelligence, machine learning, for example, as Frank said, on high performance computing applications, that's a very narrow focused capability that's being developed, and it's really cool. But one thing that John mentioned previously that I think is really applicable to this is using this capability as a native platform approach, Tyler mentioned it as well, in order to augment the ability of humans to make the correct decision and move from a reactive management style in the federal agencies into a proactive style where you're actually getting ahead of problems, you're solving issues before they actually become problems. And when you talk about cybersecurity, this is a critical defense mechanism that we can take advantage of with this technology.
I think it's one of the most core and relevant areas to the common civilian government agencies at large, right, to do some of that predictive nature. John, how about over at ODNI in regards to lessons learned? I'm sure that you guys are taking a lot of this stuff, you're putting it in the lab, you're incubating it, you're porting it out into the community, and what are you experiencing there in regards to adoption, et cetera?
Right, so a couple lessons learned. One is, I think, a common thread across everyone that data is the fuel that makes this system work. And specifically in the community, our data is a little bit different. Buzz mentioned this earlier, but the intelligence problem is different, right? We're interested in kind of the long tail of things that aren't what the large ML providers that you would think of are focused on, right? So a lot of the stuff we can't pick it up off the shelf because we're not really interested in classifying cats versus dogs, right? Our problem's different, our data's different. So we have some issues there where we have to create some data for these applications that doesn't readily exist off the shelf. And then kind of feeding into this as well, we have lower fault tolerances, right? We're very focused on artificial intelligence assurance, artificial intelligence security. And this is things like people have probably seen, the New York Times has written about things like adversarial examples, where if I have a picture of a panda, I add some pixel noise to that image of a panda and it misclassifies it as a gibbon, right? And you can do this a few ways. You can do it just where you lower the accuracy of a classifier overall, or you can do targeted misclassification. So there are ways to manipulate these classifiers if you're an adversary that we are very concerned with. And again, if you're Google, you're less concerned with this. When you're sitting in our shoes, you're more concerned with this. So this is an area that is very foundational machine learning theory that we're worried about, but the science doesn't really exist for it yet. So we're exploring that frontier of AI assurance and AI security as well.
Right. And well, that's a good dovetail into the challenges that we're all seeing here, right? In regards to the adoption of this type of technology. Let me start with you, Tyler, over at Splunk. What are the challenges that you guys are experiencing there that are, barriers to full adoption of this capability, perhaps?
Sure. I think what I see with a lot of our customers is it comes down to finding the right people internally to solve the problem. I suspect there's going to be a huge uptick in data science on resumes and things like that. And it's, cutting through that, finding the people that actually know, finding the people that know data science and the specific problem you're trying to solve is very challenging. And so for us, I see that challenge we're trying to build out the capabilities in our products to solve the problems that we're really good at, so that you don't have to have that data science knowledge for every problem. But again, I think being able to define the problem and being able to have the right people to attack the problem is one of the biggest challenges I see.
Yeah, I mean, there's a lot of articles written out there about the skills and sort of what makes the right kind of background to sort of teach a data scientist how to become a data scientist, right? They don't. They're not born with that capability.
Right. You may know the math, but if you're looking at some of the more sophisticated attacks like WannaCry or whatever that actually have algorithms behind them, you have to know the specifics of that and know what's your target to be able to tackle that problem.
Sure. How about at NGA? I'm sure you've got a lot of lessons learned over there, Buzz, in regards to adoption of this capability.
We do, and it really centers on what everyone has talked about before. So specifically, and I'll repeat myself a little bit, that clarity of objective to then align to, if you have your simplistic problem that you're beginning with, we've learned lessons on the quality of the data to train networks, neural nets specifically, to look at the kinds of signatures, so in text mining, from a data mining, from a natural language processing perspective, there's a lot of precision. There are domain differences in terms of what we think of accuracy, back to that safety of navigation, versus a generalization, hey, it's accurate enough that from a commercial perspective it's in this region or it's in this state. And every domain is different. So clarity of objectives, setting things up, and being willing to do two simple things, and they're not simple. Iterate and investigate your problem, make changes when and where you need to, and to have the strategic patience to continue to pursue and understand things. If we don't achieve a result for a certain period of time, it doesn't mean you're not growing, it doesn't mean you're not learning, it means that you haven't yet gotten to your result. You're continuously improving. Sometimes we've seen early efforts not achieve a result and they get turned off, when in fact they're progressing and raising the state of the art, they're raising your experience and expertise level, and you're benefiting overall.
How about the skills? Any challenges in that area as far as developing the skills, or anything that you can talk about?
Yeah,
here
absolutely. Absolutely. So I have the privilege of leading a group of individuals with a lot of varieties of experience and expertise. We've had a large brain drain of experienced individuals. I've been in the community for 36 years. Many of my peers have gone for a variety of reasons, and a lot of very well-meaning, highly experienced, very technical people have come in. There is a learning curve to understand the domain, understand the data, understand the mission and how to apply. That, in my estimation, is not something that is commonly understood. So taking, as Tyler talked about, take a fresh data scientist and be able to turn them on to a specific problem isn't understanding the science, it's understanding the science, the mission, the domain, the realities, the data, and that entirety takes a good amount of time.
Very, very sophisticated challenges on a very sophisticated technology. Well, we're going to take a short break here. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com. With me on today's show are Buzz Roberts with the NGA, Frank Indiviglio with Noaa, Dr. John Beieler with ODNI, Bob Osborn with ServiceNow, and Tyler Muth with Splunk. We were talking about challenges, and I wanted to go over to you, Bob, at ServiceNow and talk about the challenges that you're experiencing, maybe the challenges you're seeing internally within ServiceNow, and perhaps the challenges that you're seeing agencies as they try to adopt this technology.
Well, thanks. You know, Luke, we really have a challenge when you talk about data normalization. So in order to allow the technologies and the algorithms associated with the machine learning and artificial intelligence technologies, we have to be able to have data sets that are aligned and normalized for those scripts to actually run on. And I think Tyler really hit it on the head. You know, being able to do a lot of pre-work and setting up the data so that it's ready to be crunched, if you will, by the algorithms is all good if you're doing analytics, deep analytics on specific subjects for research type efforts. But when you're talking about data streams in real time in order to respond to events that are happening in the enterprise, that's a different way to look at the problem. So you have to normalize the data and have it in a common data store, if you will, a configuration management database in our case, so that you can run those scripts on it, so that you can take action. I mentioned previously anomalous behavior being an example, in near real time so that you understand what's happening in your environment. That's a different approach to applying the technology. It's something not all agencies have really wrapped their heads around yet, and it's a significant challenge going forward when you look at applying this to a real world set of data in real time.
Yeah, and I would imagine, you know, the challenges of unpredictable, unstructured type data is all over Noaa for sure, across the oceans, et cetera. So Frank, tell us about some challenges. I'm sure data is one of them that you are experiencing as you start to adopt this capability.
Sure. I think our challenges aren't very different from the ones we've been discussing here, specifically around the human talent part. For us, we're kind of dealing with three different topics or subject matter experts, right? We have the science experts, which we need computer science folks to tune and translate that into algorithmic and models. And then now the data science folks to come in and kind of be data stewards and build a platform that we can get knowledge out of. Those folks are hard to find by themselves. It's even harder to fuse those talents together for your specific domain. So finding and growing that talent pool within the agency, within the contracting force around the agency is a challenge for us. I think it's a challenge in general for most of us, but around this area it'll be a little bit more of a stretch to get another discipline in there and working alongside the science and computer science folks.
Right, and then just trying to sort of organically incubate that kind of capability versus trying to acquire it. And I know, you know, a lot of these agencies end up poaching their technologists and skill sets from each other a lot of times, and then you're dealing with you know, the competition of the private sector, who's also in the mix there, right?
Yeah, and making these things available and understandable to all three of those.
Sure.
Kind of groups, right? So everybody sees the world a little differently, and making the ramp to entry for all three is a challenge in itself.
Right. Dr. Beieler, how about over at ODNI? I'm sure there's a plethora of challenges that you could highlight for us.
Yeah, so coming back again to the data, a little bit of a broken record, but you know, there's policy considerations around sharing data within the community. There's considerations about how we tag things for, you know, access to make sure the right people are looking at the right data, but also tagging it to train some of the algorithms that we've been talking about today. So there's that consideration. We have to be careful about how we tackle these things in terms of training data and training these algorithms. But the second is cultural considerations, right? And engendering trust in these algorithms. Because these are, you know, speaking to neural nets specifically, they're black boxes, right? And we're dropping these on analysts saying, you know, here's some probabilistic output based on lots of training data that's lots of nonlinear transforms inside of it. Now trust what this algorithm tells you. And kind of this goes into explainable artificial intelligence, this goes into other methods of engendering trust, but really making it to where, again, going back to the idea of augmenting the intelligence analyst, making sure that this human-machine pairing can work well is something that is non-obvious and isn't, again, going back to the idea of commercial partners, isn't something that lots of commercial partners have to tackle in their day-to-day workflow, where we're trying to very closely marry human-machine teaming.
Right, and I know there's a delicate balance too with data bias and sort of just trying to, you know, sort of stay neutral in that regard so the models are pure and accurate and give you the type of outcome that you want. Well, we love to talk about the future and end up with the with the show, with talking about the future and sort of predictable. What does that look like out there a year or 18 months from now? We're going to start with you again at ODNI, and just give us sort of a lay of the land in the future in regards to you guys are sort of in the future right now. What does that look like in regards to ODNI is concerned?
Right. So speaking kind of greenfield research, take the liberty to quote Sue Gordon, our Principal Deputy Director of National Intelligence, where she said, "If it's knowable and it is important, then we know it." So that's really what we're gunning for with the ML AI marriage with the intelligence analyst. So my dream is to basically be able to know what an analyst's information needs are, sift across multiple data silos, and then rack and stack the information and present it to an analyst, and present the most relevant information to an analyst in real time or near real time. So that way, if it's knowable and we know it, and it's important, then we get it to the analyst in a timely fashion. So that's really what all this, the fundamental R&D that we fund at IARPA, the work that I think people like Buzz and others in the community are working on, that's really what this is all gunning towards.
That's just, that's awesome. Bob, how about at ServiceNow? What does the future look like?
So it's a really interesting crystal ball type of a question, but we really are looking at addressing the people part of people, process, and technology when you look into the future and how this type of technology and future technologies are going to impact people in the workplace. We see fear right now. So a lot of people, when you say AI, right, they're thinking of a sentient being, a Terminator that's going to turn on us and kill us all.
Well, and they're also thinking about their own jobs and
Exactly
their livelihood.
right.
There's that going on too, right? And the NGA experienced that, and others.
Exactly right. So that fear of losing their job is what we've really been looking at. And John mentioned it previously, at this blended workplace. And that's really what we see in the future. The ability for humans and the uniquely human decision-making processes to be augmented by machines, by machine learning and artificial intelligence. And we really look at that type of an environment as it grows and it matures, impacting the policies that are going to be put in place by federal agencies moving forward. There's a term, you've dealt with it as I, and all of our colleagues here have, that inherently governmental functions, those functions that must be performed by federal officials. In this new environment, we see that there's going to have to be a new definition. That's inherently human activities. Those activities that are reserved for a human decision maker, augmented by machines, but made by people.
Inherently governmental and pending agency approval. Those are two terms that, just stick in my head. Very good points raised by you, Bob. How about over at Splunk? Tyler, tell us about, sort of what does the future look? You guys are right in the middle of a lot of this analysis that's going on. You're collecting a lot of this data. What's that look like? What does that product set look like? You want to give us a roadmap out here, maybe a press release?
I can't do any press releases or roadmaps, but I can paint a broad picture of the future. First, I'd say that in the future it's going to be easier than it is today. A lot of things that people are doing in a custom fashion are going to be built into the product, and a lot of what our customers are doing are driving our product. And so it is going to be a lot easier, and that's going to come in the very near future. It's going to be a lot less code and a lot more push button. And the second thing is time. A lot of what we're focused on is time. Being able to predict things in the future, being able to predict an outage before it happens, being able to reduce the mean time to recovery. So, IT systems are complex. They're made up of all these components. And when things go south, you end up in a war room like this with a lot of finger pointing. And we're using algorithms to more accurately figure out the cause of either an outage or something that's leading up to an outage ahead of time. Detecting unknown attacks before they penetrate all the way into your IT systems, and also to be able to forecast. Maybe that's resource utilization, so you can better plan for your budget in the coming year. So all these things are about time, and it's going to be a lot easier than you think it is.
Yeah, I would imagine that one of the biggest areas for the vendor community in particular is offering the ability to be much more accurate and predictable, anticipate, as you're, again, training these models right, and some of this regression, the ability to then predict some of these capabilities, particularly in the security area,
Sure.
it's just got to be a slam dunk, right? I mean, I think we're all waiting for that day, right, where we can take some of that de-risk and take it off the table. Frank, how about at Noaa? What does the future look like there in regards to machine learning and artificial intelligence and our ability to get way down in the ocean and see things and understand things that we have no idea of today?
So I think that, in the short term and the long term future, it'll move from more of the data analytics or data preparation phases into augmenting the forecasting, right? So looking at ways to use machine learning to kind of test out our theories about uncertainty and parameterization models, expand the modeling set now to explore higher resolutions for really tough computational problems like cloud resolution within a global model, which is computationally expensive, and it's a little bit out of our reach now. I think the machine learning will pull that back in, and then better forecasting ability, right? So we're looking at ways for pattern recognition and feature detection in the data sets we have, and that'll help with cyclone detection and El Nino and the southern oscillation process, which drive the atmospheric process that we model. So.
Right, and I would imagine that then gets cranked into the Weather Service, right, to really put a fine point, and the accuracy is just, if you look over the last 10 years, it's just incredible what's going on. I know there's this wrestling match with the USA model versus the European model, et cetera, but I think competition is what made this country great, and I think it's fantastic that we're able to pull all this type of data in and be able to make very accurate forecasts, which are saving a lot of lives, right? I mean, let's face it.
And it's all about responding, getting warnings out, and making sure the public's aware and responding to extreme events. And not only augmenting. I mean, Bob mentioned augmenting people, but you're also augmenting the modeling suite so that you're making better predictions.
Right. Buzz, how about over at NGA? What does the future look like in regards to all this imagery data? We were talking yesterday about the literally hundreds and thousands of micro satellites that are being thrown up in the air, and I know you all get a lot of that data from obviously from the federal launches, but there's a lot of private satellites out there as well that I understand that NGA takes a lot of that data in as well. So what's the future look like as we have this sort of constellation of satellites out there collecting all this information in a very sophisticated manner?
Well, thanks for the question, Luke, and the opportunity. Our vision is to advantage what we refer to as the global GEON enterprise. So again, as an IC organization, it's a bit underrepresented that we actually do have that open unclassified mission set, and we're partnered globally, and we're partnered with the open community more than most. So our vision is to leverage everyone's expertise, everyone's experience, bring that together through these things I've mentioned: clarity of objective, bringing people who understand the data, who understand the principles and the science, and who can help us transition from a chiefly human-oriented enterprise to shifting that so we can raise our analyst expertise from the mundane and rote activities to what really is challenging for the human brain and the right approach to take advantage of. Fundamentally, that crystallizes the data to decision timeline, which, quite frankly, based upon the mismatch of data pixel to pupil ratio, as we like to refer to it.
I like that. Pixel to pupil. That's a new one.
It is overwhelmingly deluge of data to the few eyeballs and experience that we have, and shift that to discovering the data, discovering what's knowable in the data, not necessarily in the raw pixel information. That involves fundamentally focusing on, and I heard the term used, but real-world AI. And real-world AI is, again, focused on clarity of objectives, clarity of understanding, raising your experience and expertise base as we move forward. One challenge, if you wouldn't mind, I'd like to highlight is that's going to shift us all from thinking about products and services to thinking about knowledge. and how do you procure knowledge, how do you incentivize knowledge, how do you sustain knowledge. That's different than the classic, I want to buy a product and then use it. When the ecosystem of what happens on the earth changes daily, buying a product to look at that ecosystem is out of date once you've received it. So how do we get into that rapid adaptation and flexibility? That's informed by, I would argue, clarity of objectives and understanding the domain that you have to actually action.
Yeah, it's interesting because, 25 years ago, 30 years ago, I've lost count, I was at Ford Aerospace and we were putting birds up in the air and we were thrilled at a meter, right? And now you have these micro satellites out there that are not only taking imagery, but also, taking all kinds of other sensor information and being able to sift that up and process it. I find it refreshing that we had a conversation over the period of an hour here and not a lot of conversation about technology and the technology itself needed to actually process this capability, et cetera. I'd like to just spend a minute and talk about sort of the acquisition community, if you will, and the acquiring of this technology. And is that a barrier? Is that a challenge? Is that something that you guys are dealing with in regards to getting access to this type of computing to be able to do the things that you need to do in machine learning and AI? Let's start with you at Noaa, Frank. Just any sense there of any challenges? We got about a minute and a half here. I just want to do a little turbo round.
Well, yeah, so
yes,
I think,
no?
So for us, I think access to computing and having the right amount of computing is the answer is always never enough.
Yeah.
And I think there's further complications in the market, right? We have new technologies out there that may or may not work well within our application set, and we have to go out and do the investigation and how to incorporate these different things. So I think we're used to, this big monolithic thing, and then how do we incorporate different types of processors for machine learning, for data acquisition, things like that.
Yeah, and it's sort of GPUs by the drink, and I think about things like quantum and when that becomes available and sort of the gateway that's going to open up. And to the degree that you can talk about it at NGA or perhaps at ODNI, any barriers there as far as accessing the type of technology that you need to? Yeah, we got about 15 seconds, so just let me throw it over to ODNI to wrap it up here. Yes, no, plenty of technology, you're developing it.
No, because I get to fund people developing the technology, so that's my acquisition, is funding the basic R&D and hopefully be able to punt that over to people like Buzz and others within the community to then use. So no, luckily I don't have to buy AI solutions. I fund the basic R&D, so maybe Buzz can...
So John's right, he's funding it. I have to prove how much we need. So to your comment on quantum, how much quantum do you need? I need practical experience, evidence, and data to prove and be able to support my budget estimates. Without being able to take some pilots, take some activities, it's difficult to prove that. And we've got our 5-year budget cycle. So how do you forecast what you need in the future? You have to have experience and evidence by doing it today. We've talked a little bit about that. That's, I think, our biggest challenge. How much do you need in the future when we have to forecast 2, 3, 4, 5 years down the road?
Well, perhaps that's a topic that we'll discuss more in length at a different time, but we're going to have to wrap it up. I'd like to thank today's guests for taking the time from their busy schedules to join us for this program. I'd like to thank our sponsors, for without we don't have a show. I'd like to thank the good people here at Federal News Radio that make our program so successful and enjoyable. And most of all, I'd like to thank you, the listening audience out there that tune in every month. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM and federalnewsradio.com.